Ladies and gentlemen, you should have mastered your I can sheet, I can density. So let's go over some things. Label each block with the following terms: medium dense, most dense, and least dense. You're going to be using the ed puzzles to answer the question. So which one do you believe is the most dense? So look at the boxes. You're looking at the one that has the most mass per volume. They're all the same sizes. So the most dense one would be letter A, because it has the most stuff packed inside. The least dense one is going to be letter C, because it has the least mass, or the least stuff. All three of these are models. Okay, excellent. Let's go to the next. This is a picture of a graph. Mix and dry with an X and a Y. Where are we writing mix? We're going to write that on the bottom. Why do we do that? Because the volume is your manipulated independent variable. It belongs on the x-axis. So what is that being related to? The data you're going to collect is going to be your mass, your dependent responding variable. So when we compare the mass versus the volume, we're going to have the effect of the mass on the volume of certain substances. I abbreviated that, M on V. And typically, mass and volume will be able to calculate your density. So let's look. It's asking you to choose two of the substances. Now they have a little T on the side. So the heart is the water. The wood pine is the cross. The iron is that little rectangular shape thing. And the aluminum is the star. So, step one, if we want to calculate the formula, if you want to calculate the density of a substance, you need to remember the formula. So you need to love density as much as I do. And recognize that density is equal to mass divided by volume. M over V. Substitute. All right, well, we have to look for the M first. Don't go on the x-axis because that's volume. Go over to the mass. So, which one are we going to do? Let's choose the aluminum first. The aluminum is the star. So let's go up to find the mass of the star. Let's go over to the star. So what's the mass of that? It's going to be 80.0 grams. No naked numbers. Now, we also need the volume. So how do we find the volume? The volume's along the x-axis, Go down until you hit the volume, and that's 30. And they want you to label that milliliters. So 80 divided by 30 in your calculator, please. What did you get? 80 divided by 30 is equal to 2.666666. Forever and ever and ever. It repeats. You must round to the nearest tenth because our instruments can only go to the tenth. So how do I do that? How do you round to the nearest tenth? You need to take the 10th position. Now, is this closer to 2.6 or 2.7? How do you figure that out? You have to go next door. So go next door. 5 or more, up the score. 4 or less, let it rest. Is the 6 greater than 5? Yes, it is. So you're going to make this is going to be 2.7 grams per milliliter. We don't want this because it's closer to 2.7. So aluminum is 2 and 7/10 grams per milliliter. Let's pick another one. Let's get a line that's lower than the aluminum. I like this line. This line is the wood pine. So let's find out what that is. The density formula doesn't change. Density is equal to mass divided by volume. Second step is to substitute. How do we substitute? You have to find the mass. So here's your dot. Go over to the mass. Oh, well, my mass is 30. That would be naked. You need to add grams. What's my volume? My volume is 60. 60? It's saying milliliters. I'd like it to say centimeters cubed, but that's okay. We'll stick with milliliters. When you divide, what number goes in the calculator first? The 30. 30 and 0 tenths grams divided by 60 and 0 tenths milliliters, your answer is going to be 0 and 5 tenths grams per milliliter. Look at the line. This line is lower. What does that tell you? It has a lower density. So what if I wanted to make another line on this graph that had an even lower density than the pine? Where would it go? Where would the line go that had a lower density than the pine? Would it go above the pine, on the pine, or below the pine? It would definitely go below. So this dashed line or dotted line would show a density that is less than the pine. All right, let's look at the other questions, shall we? Draw a dashed line on the graph that represents the substance that's less than wood. Oh, we did that already. What would happen to the density of a wooden block if I cut it in half? Well, what do you think happens to any pure substance if you cut it in half? If you cut a pure substance in half, the density stays the same. The density doesn't change. Why not? It's a pure substance. It's a physical change. You're not changing the molecule arrangement. You're just cutting it in half. Because density is a ratio of mass per volume. And when it's a ratio, you cut it in half, you're going to decrease the volume, but you're also going to decrease the mass at the same rate. So let's prove it. Let's redo. What are we going to do? So it says, write the formula. Density equals, same formula, doesn't change, mass over volume. Now substitute. The mass of the substance is 20 and 0 tenths grams. The volume is 26.0 centimeters cubed. You want to plug those numbers into the calculator, and you're going to compute that as 20 divided by 26. 20 divided by 26, and we get 0 and 76 hundredths. That is not to the nearest tenth. It's a bigger number. 7692307. But I didn't have to write that much because all I want is to the nearest tenth. Look, this is the 10th spot. So it's either going to be the same or greater. That's the only option. So it's either going to be 0.7 or 0.8. Is this closer to 0.7 or is it closer to 0.8? Let's go next door. The 6. Up the score. So it's going to be closest to 0.8 grams per centimeter cubed. That's not correct. What happens when I cut it in half? I just said density is a ratio. So density is mass over volume. If I cut the mass in half instead of 20, I'm going to have 10 grams. That's half. But now I'm going to cut the volume in half as well. Instead of 26, I'm going to have 13 centimeters cubed. So 10 is half of 20. 13 is half of 26. What happens when I plug those numbers into the calculator? 10 and 0 tenths divided by 23. I get, I'm sorry, not 23. 10 divided by 13. I get the same answer. Why? 0.76922307. I get 0.8 grams per centimeters cubed. Why does that happen? Because density is a ratio. So it's half the size and half the mass. Its molecules are still in the same positions. So density is the amount of mass you have per given volume. The volume smaller, so is the mass. The density stays the same. Let's go to the next page, shall we? This is a challenge. A little aluminum boat has a mass of 14 and 5 tenths grams. Has a volume of 450 centimeters cubed. The boat is placed in a small pool of water carefully filled with pennies. If each penny has a mass of 2.5, how many pennies will be added to the boat before it sinks? The aluminum boat. Aluminum has a density of 2.7. So why is it floating? Because the aluminum boat is hollow. And given that it's hollow, we can fill it with pennies. So when we add pennies to it, we're going to fill up the hollow space with more mass. So the volume is equal to 450 centimeters cubed. And the mass of this whole little aluminum boat is 14.5 grams. Not centimeters cubed, but grams. Now, each penny has a mass of 2.5 grams. How many pennies will it take to sink the boat? So let's see. Density is mass over volume. You need to know that water has a density of 1 gram per milliliter. So in order to sink the boat, the mass needs to be greater than the volume. So right now, our volume is 450 centimeters cubed. You want to sink your boat, you got to get your volume to be equal to 450 centimeters cubed. And right now, I'm sorry, your mass has to be equal to 450. Right now, your mass is only 14.5 grams. And I want to subtract the 450 from that. And I'm going to get how many grams to fill the boat. 450 minus 14.5. So in order to sink the boat, I need 435.5 more grams. Because you know, if you have water, I want the boat to be here, it's sunk. Anything greater than 450 will sink the boat. So, if I need 450, I'm going to divide that by 2.5, and I have 174.2. You can't have a piece of a penny. You have to have 175 pennies. That will sink the boat. 175 times 2.5 is 435.5, and that's how many pennies we need. I took this number, divided it by 2.5, because I know that in order to sink the boat, the density has to be greater than 1. So I made it equal to 1 and then added a penny to it. 174.2 is what's going to make it equal to 1. Add a penny, 175. I hope you enjoyed the video and completed the end puzzle. Have a great day.